Hello, so today we are going to go over parts of Unit 8, Lesson 9. So this is the motor and generators lesson. So today we are going to go over how a motor or a device that runs on electricity can actually get electricity without having to have a battery or other supply of the electrical current. So today we are going to look at, I have a flashlight here. And the first thing you kind of notice is that there is a copper coil that runs all the way around inside, and there's actually a tube that runs through it. So if you look, you can see that there is part of the copper wire that runs from the spool up to the on and off switch. And actually, if you look back behind the on and off switch, there's actually a capacitor that actually will store some of the electrical current. So how does the electrical current get produced in this system? So that's what we're going to be looking at today. So if you look, there's a metallic magnet down here at the end, and that actually is able to move from one end to the next. So if I take a bobby pin, you can see that it wants to go to the magnet. It's attracted to that magnet. If I actually put it on there, I can actually get it to follow that magnet back and forth. So what about the magnet is so special that it wants to attract this hairpin? Well, the magnet has that magnetic field or magnetic current all the way around it, so no matter what direction I put this in, I can get the hair clip to stay on it. It doesn't do that but here because there's no magnet and the plastic is not magnetized. So it only wants to do that where it is. So you can actually tell when that electrical field is actually strongest, and you can actually feel it going weaker as you get farther away from it. So what's going on is as you slide that magnet back and forth in the middle of this coil, it's actually allowing the electrons around that magnet to be transferred into the coil wire, and then it actually transports those electrons in that electrical current now up to the capacitor where it is stored until you turn on the on switch and turn on the flashlight. So let's go ahead and look at this another way. So if I have my copper coil and I have my magnet here, remember that magnet is going to have that magnetic field around it. So you can actually kind of draw that in. I'm just going to use dots to kind of represent it. And that's coming off in all directions. So it's 360 degrees around that magnet. I got my copper wire going to the capacitor. Alright, so as that magnet moves back and forth through the copper wires, what you're going to see is that these electrons, which if you remember, if you think like an atom, if it doesn't have that full octet, it wants to get rid of one of them so that it has that full energy level. Well, you can kind of think of that all of these electrons around the magnet is kind of like that one electron that it wants to get rid of. So it's going to freely give those up into the copper wire. So now the copper wire is going to be slightly negatively charged because it's going to have extra electrons. And now you can kind of think of it like when we had that when we were looking at the batteries. So the positive end of the battery and the negative end, remember the electrons flow from the negative ends and they're trying to get away from the other negative electrons. So if the copper wire is now negative, now once you get to the capacitor, it's going to allow those electrons to move up that copper wire to the capacitor. So they're going to be flowing to get away from each other. So now if you turn on the flashlight, you're going to see the electrons from the capacitor used first, and then if it runs out of electrons or current in the capacitor, you can keep moving this back and forth to get more electrons going to increase this flow. So once this is on and you hit that light switch, your light then will turn on. So if you think of that as a circuit, without having that energy source, it doesn't have the electrons flowing, so it doesn't even have the current. So now we have that electrical current that's flowing, and we can now use that to complete the circuit and to turn on that light bulb and actually now be able to use the flashlight without having to worry about batteries. Thank you so much for watching. If you have any questions, make sure you let me know. Thank you.